Part C, it's asking for what x values is f concave up. So to be concave up, that means the second derivative must be positive. But we're only given the graph of the first derivative, so we have to somehow come up with information about the second derivative from this graph. Well, second derivative is just the derivative of this. So if we want to find the values where the second derivative is 0, we're looking at this graph and trying to figure out when is the derivative, or the slope of the tangent line, 0 on this graph. Well, that's going to happen wherever we have those local mins and local maxes. So at -3, 0, 4, and 7. Right, each one of those has a derivative that's 0, so that means the second derivative is equal to 0 at these values. So that's where the second derivative could potentially end up changing from positive to negative or negative to positive. So we have values of -3, 0, 4, and 7. Now we want to look at the second derivative in between those. So we're just looking now, again, at the slope of this graph. Right? The slope of this graph is the derivative of the graph, or the derivative of the derivative, which is the second derivative. So to the left of -3, over here, the slope is positive this whole time. Then between -3 and 0, from here to here, slope is negative the whole time. From 0 to 4, slope is positive. From 4 to 7, slope is negative. And then from 7 on, slope is positive. So in part C, we're trying to figure out when it's concave up. That's going to happen when the second derivative is positive. So we have 3 intervals there, from -infinity to -3, 0 to 4, and from 7 to infinity.